Hello friends, welcome to engineering tutorial. Today's topic of discussion is Zener Diode. So basically what we are doing is we are taking forward the discussion about diode application or semiconductor diode application. So you can say that Zener Diode is one of the applications of a normal PN junction diode. Okay. So we will discuss about the specific application of Zener diode in upcoming videos, but in this video we are just going to study some of the basic concepts associated with it before we go in deep into the in-depth analysis of Zener diode. So we will divide our discussion into various parts. First we will understand the definition, then some of its unique properties, and then the schematic symbol. So as you can see, let us first define or first understand the definition of a Zener diode. So you can see the definition here. It is a properly doped PN junction diode which has a sharp breakdown voltage. So from the definition you can understand that a Zener diode is a normal PN junction diode which consists of a p-type semiconductor block and an n-type semiconductor block comprising the cathode and the anode. So it is a normal PN junction diode, but the question which needs to be addressed is that why and is it called as Zener diode and not a PN junction diode, and what characteristics or properties it possesses that differentiates it from a normal PN junction diode. So there are two unique properties associated with a Zener diode which separates it from the class of normal PN junction or semiconductor diodes. Okay, so the first property or unique property of the Zener diode is that it has a sharp breakdown voltage. Okay, it has a sharp breakdown voltage. Now when the concept or the term breakdown comes, you must understand that it is in some way related to reverse bias mode of operation. Okay, it is related to reverse bias mode of operation because breakdown can only occur, breakdown of a diode can only occur when it is connected in reverse bias mode. So from this term you can make out that the second unique property of Zener diode is that it is always connected in reverse biased mode. A Zener diode is always reverse biased. Now the normal PN junction diode is always connected in forward bias mode. We have discussed that, and that property is utilized in various applications such as half wave rectifier, full wave rectifier for conversion of AC into DC, where a diode, a PN junction diode in forward bias mode is connected, and it conducts only current in one direction, which helps it converting AC into DC. But here a Zener diode is always connected in reverse bias mode. So the concept of breakdown voltage can come into play. Okay, so these are the two main properties, two unique properties of Zener diode which separates it from the class of normal PN junction diodes. First, it is always connected in reverse bias mode, and as it is connected in reverse bias mode, the concept of breakdown voltage comes into play, and it has a sharp breakdown voltage, and that value of sharp breakdown voltage at which the breakdown of the diode occurs is called as Zener voltage. There is a unique name for it, okay, and that voltage is called as Zener voltage. So next is the schematic diagram or the symbol of a PN junction diode. The Zener diode. So as you can see, it looks more or less the same as that of a PN junction diode, but the difference comes in this part, this Z-type symbol or the Z-type shape that you can see. Here the p-type end is the same as that of a normal PN junction diode, a arrowhead or a triangle you can say, but the n-type end, instead of a normal straight bar, here there is a Z shape. okay, a Z shape which denotes the word Zener diode, okay, this Z shape, it denotes the n-type end, and this symbol or this shape makes us recognize that this diode which is connected in a circuit is a Zener diode, and it is not a p-n junction diode, okay. So whenever you come across a circuit which has this type of shape or this type of diagram with a normal arrowhead followed by a Z shaped symbol, you can say that the diode connected in that circuit is a Zener diode, okay. So we discussed about the theoretical definition of a Zener diode, its two unique properties and the schematic symbol. But now let us understand how we can make out the difference between a normal p-n junction diode and a Zener diode when we look at a circuit connection point of view, okay. Whenever you look at a circuit, how can you make out the difference between a normal p-n junction diode and a Zener diode? Now, on the left hand side, it is the circuit connection of a normal p-n junction diode. Okay, so you can see it is the symbol of a normal p-n junction diode, which is an arrowhead followed by a straight bar. Now, the critical difference between the p-n junction diode and the Zener diode. Now see the circuit connection. The p-type end is connected to the positive terminal of the supply voltage, and the n-type end is connected to the negative end, okay. P-type end connected to positive, n-type end connected to negative, straight away it is a normal p-n junction diode. It means that it is in forward biased connection mode, and this is a normal p-n junction diode. So this is the first point. A normal p-n junction diode is always connected in forward bias mode. It means p-type end connected to positive, n-type end connected to negative of the voltage supply. Now, the Zener diode. First, the symbol. As you can see, it also has a normal arrowhead as that of a p-n junction diode, but here the n-type end is a Z-shaped symbol, okay, a Z-shaped symbol which denotes or indicates that it is a Zener diode, okay. Now, the second critical difference, the n-type end is connected to positive. The n-type end of Zener diode is connected to positive terminal of the supply voltage, while the p-type end is connected to negative, completely the opposite of a normal p-n junction diode. Now, whenever a diode is connected in this form of arrangement, it is called as reverse biased mode, reverse biased mode, okay. So, a Zener diode is always connected in a reverse bias mode so that we can achieve breakdown of the diode, so that we can reach the Zener voltage. For that and that purpose alone, the Zener diode is always connected in reverse bias mode. Breakdown cannot occur in forward bias mode. Breakdown can only occur in a reverse bias diode. So, Zener diode is fabricated using the same technology as that of a normal p-n junction diode, but it is specifically designed to achieve breakdown at a certain critical voltage which is called as Zener voltage, and it is properly doped, okay, so that it can achieve breakdown at that particular voltage. That is the only fundamental difference between normal p-n junction diode and the Zener diode in terms of fabrication, but the same other characteristics will be the same. It is a normal p-n junction diode, but it is fabricated in such a way using proper doping mechanisms so that it can achieve breakdown at a certain reverse voltage to achieve breakdown, which is called as Zener voltage, and it is always connected in reverse bias mode, and has a sharp breakdown voltage. That is the only difference between a Zener diode and a p-n junction diode, okay. A p-n junction diode is always connected in forward biased, a Zener diode is always connected in reverse bias so that it can achieve breakdown condition, okay.